The first time I did one of these presentations, I got up here and I started talking for about 3 minutes, and then my presentation partner said, hey Dennis, maybe we should introduce ourselves to the audience before we keep talking. So thank you for the reminder. My name is Dennis Liu. I'm a product manager on Confluence Cloud. I work on performance. Ilya is my engineering manager, also works on performance. Today we're going to talk about both how we think about performance and the roadmap going to the future, and then in the middle we'll talk about the things that we've done so far. Hopefully you've all experienced this on Confluence Cloud. So that was the agenda. How we're going to measure is going to be a little complicated, so I'll just dive right into that. Turns out measuring performance is really, really complicated. I'm going to use a bunch of terms and words here and explain some of them. If you want to ask about them later, that's great. So the first question we always have is, what should we measure, right? Do you want to measure when the page is readable? Do you want to measure when all the features are usable? Do you want to measure when the browser's done loading everything? Do you want to measure the average? Do you want to measure the median? Do you want some percentile, right? Like these are all things that you can look at when you're measuring performance. Another problem you have, what do you want to compare against? Which metrics of all the ones you're measuring are key that you want to compare against somebody else? And then which competitors or comparison points do you want to use? Then, of course, in performance, there's also an issue around user experience. Performance is not just about numbers. It's not just whether it's 5 seconds, 4 seconds, 3 seconds, or 2 seconds. It's about the user experience of performance. I'll explain a little about what that means later. So we can't do all of those things that we just talked about. So we're going to explain which ones we've chosen to focus on for the last little bit. First, what to measure. We want to measure when all the visible features are interactive, because we have this understanding that until everything on the page that's shown is interactive, users don't really think like it's done loading. And really, that's the end measure. Do you feel like the page is done loading or not? And then the next thing we want to do is measure P90. So this is the 90th percentile. If we take everything within Confluence Cloud and we order it from fastest at the bottom and slowest to the top, what's the P90, the 90th percentile of that? The reason we pick that is because we don't want to leave out too many users, right? But we also don't want to include, say, P99, where a bunch of weird things are happening up there. Then on the what to compare front, I don't know how many of you have experience with Confluence Server, but we are comparing ourselves against Confluence Server because we get a lot of people that are migrating that have comments about performance. And the thing we're actually comparing is view page. So we have stats about how often view page gets loaded. View page is just when you create a normal page, and that's just what it looks like. I think it's about 70% of our traffic is on view page. Then there are 2 key metrics that we're looking at, and I'll explain what each one of these means. First, meaningful paint, shortened FMP. It sounds like what it says. It's the first time something meaningful was painted on the screen. Then time to interactive also kind of sounds like what it means. It is the amount of time it takes for the page to become interactive, which again, as I said earlier, that's what we're trying to measure the most. And on the user experience side, what we ended up doing was actually creating a set of rules on how to build products with user experience in mind when it comes to performance. One good example is smart defaults when you're selecting something. What that allows you to do is your end-to-end workflow will become much faster and much more seamless, and then it makes you feel like the experience is faster. So next section is understanding cloud versus server. And Ilya is going to take over here, I think? Or am I supposed to keep doing this? I don't remember. I'll do this part. OK, so here is server on the left and cloud on the right. This video was taken some year ago or so, and it'll keep looping. So what you see on the left is server loads really quickly. And most of our customers that use Confluence Server experience that and say, hey, that's fast. I like that. On the right-hand side, if you pay attention to, say, the images or the page tree on the left or the top nav, you'll see that things are popping in and then resizing and slowly loading. We use this internally to sort of indicate to people, well, this is what our customers are seeing when they come from server. To be a little more explicit, this is all the things on the right-hand side we've highlighted are the ones that are slower. Quick search, analytics, page buttons, smart links, images, page, these are all loading incredibly slow back then on cloud. So now Ilya is going to come up and talk about why it used to look this way.
I'm Ilya, engineering manager, Confluence Cloud performance team. Okay. So there are several differences between server and the cloud. And the biggest one, server, is server-rendered, old-style web pages written in Java and jQuery on the front end. jQuery is used only to make pages interactive. That's why it's lightweight, and that's what makes initial loads faster on the server. However, there are no transitions. Every navigation between pages are initial loads or full page reloads. On the cloud, we went with single page application written in React, which means we are enabling transitions between pages, and they are really, really fast. However, initial loads are slower because it takes more JavaScript with React to render the whole page. Also, cloud has more functionality, which makes JavaScript a bit heavier. So what is single page application? Or if we look at comparison between how single page application and old Confluent Server applications are being loaded, user starts by navigating to a page. Next, this is Confluent Server. Next, HTML and JavaScript are being downloaded, and this is where users already can see the page. Next step, JavaScript is being executed. That makes the page interactive. And that's it. For Confluent's cloud single page application, all begins the same. User wants to navigate to a page. Then we download empty HTML that downloads JavaScript and page data. The page is not visible at this time. Then browser executes the JavaScript, and this is where React can create the HTML, the DOM, and page becomes visible. Later on, we download more and more JavaScript to make other features appear on the page. As you can see, on the Confluent Server, page is visible in one step earlier than on Confluent Cloud. So what we did so far to address that, our solution is to bring back server-side rendering, but intelligently. What does it mean? We just want to server-side render the initial loads and keep the transitions fast as there are today with single-page application. Let's look at the page load sequence of the new cloud, which is SSR, server-side rendered cloud. User starts the navigation to a page. HTML and JavaScript being downloaded just like in Confluent Server for initial loads, and the page is visible at this point in time. JavaScript, React JavaScript, is being executed and page becomes interactive. Same as before, we load more and more JavaScript, so more and more features will appear. As you can see, we made it just like Confluent Server. We made the page appear one step earlier than before without server-side rendering on the Confluent Cloud. Here is what user sees visually. On the left, you can see the before SSR, single-page application without server-side rendering. As you can see, the initial content comes later on, and it comes partially, and then more and more things appear on the screen, and content jumps a bit. On the right side, you can see the initial load of the page in Confluent Cloud with SSR, and HTML comes significantly faster, and it's more complete, and you can see page jumps less. So what's next? Let's welcome again Dennis.
That was just step one. You can see, slide says step one. We're going to talk about what's next, and really there's three pillars that we're looking at. Lots of other things, but we start with three. First is we can make FMP faster. Again, FMP means first meaningful paint, which is when that server-side rendered page comes back to the client. The faster we make that, the faster people see their content. That should be a simple no-brainer. But there's another pillar about making FMP more inclusive. So we showed you a very small snippet of the page, but if you remember back at the beginning, we talked about images, page tree, quick search, and smart links, and all of these things that are slower. Every time we server-side render one of those, FMP becomes more inclusive, and it looks like the page is immediately ready. Then, of course, there was the last bullet on the timeline that says, talking about speeding up features. We need to speed up all the features because we know what people click on. So when we identify these three problems, it's always, well, what do you do next? Like, as a product manager, it's always asked, what do we do next? What's the most important? And to do that, we have two big boards that we use to identify that. And the first one is we call macro frequency. Macros are things like table of contents, profile, children, and so on. These sort of more complicated things that you add when you're an editor. Not, for example, tables and expands, which are we call native content. So we have analytics on the back end that says how many pages have tables of contents, how many pages have profiles, and how many pages have children. And then that tells us, we should work on that and make those faster. On top of that, we also have click frequency. Now, click frequency is very interesting because you don't always know why people are clicking on things, but you do know that they're clicking on them early, right? And so when we look at which features people are clicking on, you get edit, page comments, watch, page tree, quick search. These are not in the actual order. I didn't bother putting them in the correct order, but these are the kinds of features that people click on. So, given these two pieces of data, we're going to show you some, again, before and after animations to show you all of the work we've done and how that improves the performance experience. So very simply, on the left-hand side before, on the right-hand side after, we just did the edit button. You think, the edit button, it's small, it's tiny, why are we highlighting this? And the reason is a lot of people click the edit button. When you go and you open a new tab and you go to Confluence and you know you want to edit it, what are you waiting for? You're just waiting for the page to load so I can click one silly button. With server-side rendering of the edit button, as soon as the page loads, you can click on it. I don't have the exact numbers on here, but I think it's about 3 times faster than it used to be, maybe 3 times faster. You can also see a very interesting thing that Ilya alluded to. It's called cumulative layout shift, which is the official term, but the unofficial term is jankiness of loading, which on the left-hand side, if you look at the little inline comments button, it's grayed out and it's next to watch. And then as favorites pops in, it shifts to the left, right? That's really annoying. We discovered that that is a really terrible thing to be doing to users on a button, especially if the button moves under you when you're trying to click it. Probably the worst thing that a product can do to people. We are not running ads, and we don't want you to click on the ads accidentally, right? So this is one feature. This is a simple feature, right? But we had the other table, which was macros. So, I kind of spoiled the thing, but table of contents is a macro that a lot of people use. I think it's on the highest used macro, 15, 20%, something like that. So 15 to 20% of pages have a table of contents macro. Again, the left-hand side is before we server-side render it, and the right-hand side is after we server-side render it. And I think the biggest thing to pay attention to is the text. See the first heading there? Imagine you're reading that heading, or you're reading that paragraph. And as you're reading it, the table of contents pops in. Now you got to move your eyes, find the text you were reading, super annoying. Whereas on the right-hand side, it kind of loads like the way you'd expect it to. The page is loaded, the table of contents is there, you don't have to do anything. Sometimes when we talk about our performance improvements, it's this simple, where it's like, if you don't remember what it used to look like, and you just see the new one, it's like, well, that's how it always worked, right? That's how it should work. But in reality, this takes a really long time to do. Here's another example. This one I had to do top is before, bottom is after, because it's really wide. So quick search, hopefully, is a feature a lot of people use. It's the search box in the top right. When you load a Confluence page, you type some stuff, it shows you some results. One thing that we were noticing was that when people open a new tab and then they click on quick search, you can see in the top animation, there's that little circle that shows click, 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 click. People are clicking on it thinking that it works when it doesn't. I did mention that layout shift is annoying. This is far more annoying than layout shift. Trying to click on something, but it doesn't work. There were 2 solutions for this problem. First solution is make it not clickable and not show you, right? But that's really only a partial solution. The real solution is what we did on the bottom. As soon as the page loads, you can click on the box, you can start typing, right? You can even hit enter and it will take you to the advanced search results. This is one of the, again, more complicated things because adding this sort of interactivity into the server-side rendering is technically very complicated, and Ilya will always tell me that. Now, this is, again, only one feature. We have another one which is even more complex. We have 2 slides for this. because you might not be able to see it on the first slide, but this is page tree server-side rendering. Again, left-hand side is old, right-hand side is new with a server-side rendering. You'll see that as soon as the page loads, the page tree is visible. Not only is it visible, you can scroll up and down on it, and you can click on it. It's a funny story. I don't use page tree that often. I know a lot of my coworkers do. And one of them was telling me when we were talking about performance, he said, you know, one of the things that I do is open a new tab, but it's not the page I want to go to, right? It's the page that's near the one I want to go to. And she said, then I look in page tree and I find the page I want to go to and I click on it. And I was like, well, it's always good to talk to users and find out what they actually use our product and how they use our product. And that increased the priority of making this SSR. So I have another one that I'm just going to zoom in so you can see the explicit difference. So with page tree SSR, you get everything in place at once. With the other one, it's going to jump around and load asynchronous. Looks like we went really fast, so you all get to lunch earlier. We have, the last thing on our agenda is just to talk about our future plans. And we have sort of two major things in here. Let's just dive into the first one. So when it comes to future plans, there are two sets of things. One set is things that Atlassian can fix. We can fix how big the Confluence code size is. It's like a one-to-one relationship. The more code you have, the slower the page will load. It's really, really hard, though. We've literally borrowed resources from every team on Confluence Cloud to be fixing this, and we've been doing it for about 6 months. We've had great success. If you watch the keynote, Anu mentioned that we've improved speed by about 50-something%. That's thanks to the amount of code we've been able to reduce. The second one is API call responsiveness, which you see on the front end, but we analyze on the back end, of course. The faster the API are, the faster pages load. Should be pretty simple. This one is a little harder for us to touch, where third-party apps and macros really impact the performance of Confluence, right? If you have a page and there's a bunch of third-party macros on it, you don't care that the third-party macros are slow. You just want the page to be fast. We are trying to work with partners on making that process faster, and we're also trying to make server-side rendering work for those partners as well. But that is a very long-term plan. There's a last bullet here is very interesting. So most of you use Confluence Cloud, and you're OK with the performance. The real problem is if we get a degradation. A degradation is when performance was, say, at 5 seconds, and then it went to 8 seconds a day because something happened on our side. Maybe we released some code. Maybe we had a service go down, that kind of thing. That's also really annoying because you were used to something, and it got worse. It's terrible. So we have spent a lot of time on the back end testing and changing our pipeline around so that we could avoid degradation. So as soon as we get even, say, a 200 millisecond degradation now, we tell everybody on our team, and we go look into it. We pause rollouts for this. The second category is going to be a little more interesting, and I hope is very educational, and I hope you can all partner me with on this. There are things that are outside of Atlassian's control when it comes to performance. The first one is around network and computer hardware. So if you have slow network, your web pages will load slow. Hopefully this is not rocket science. If you have less CPU cores on your computer, pages will load slower. Ilya mentioned about being a React single-page application. That means the browser is running a lot of JavaScript. JavaScript requires CPU execution time. Same with memory. If you have only 8 gigs of memory on your machine, that correlates really well with how much you can execute. We are not saying that you have to go buy new computers for all users that are going to use Confluence. Confluence is a web page. It should work for those users. It will just work slower, but we are focused on making this better as well. Second one is very, very important. This one has even bigger effect on performance than network, CPU, and memory. If I remember correctly, network, CPU, and memory had about a 50 to 75% degradation in performance. Whereas if you have security software that downgrades your connection from HTTP 2 to 1.1, it's about 2x, 2.5x. I don't know how many network security admins are out there right now, but if you see that you're on HTTP 1.1 or your pages are loading slow, go ask your network admin. There are some simple workarounds for this. We just usually need a certain set of IP addresses or DNS entries to be opened by your network security software. But there are also some other cases where it's software that's running on your desktop. And if the software running on your desktop is analyzing every single thing, every web page that you're looking at, again, it will slow us down. And again, that is mostly out of our control. The last one is, again, a very different, interesting thing. The bigger your page is, the slower it loads. This should not be too surprising to hear. One thing that we've done in Confluence has always allowed any size you want. You can do whatever you want. You can make a page that takes 10 days to scroll through if you wanted, and it will just load slow. It will be very hard to edit. Our recommendation, roughly, I'm not going to say this is not hard and fast, is if you have a table in your page and it has more than, say, 10,000 cells in it, that means you could have rows or 1,000 columns or 1,000 rows, 10 columns, whatever. That's a lot. Okay? That's a big page. If you have trouble scrolling through the page because you can't click on the scroll bar, that's a big page. Okay? It will still load, probably. It will still be editable, probably, and we're working on that. But the more you can split up your pages from that giant size to smaller individual ones, that would help me out a lot, make my job easier. But if you can't, file a support ticket. We can talk about what kind of workarounds we have for those kinds of situations. If you're migrating from server to cloud, this will be especially noticeable because that's where we have a bigger jump in scale issues. So those are the things that we're working on and we have control over versus the things you have control over. But we're just going to talk about the things we're going to tackle. This is sort of like the roadmap part. We're not going to be too specific around here. We're not going to promise anything. We don't promise anything that hasn't shipped. First, we're going to continue shrinking the code size. This is a win for everybody. This is especially a win for those with lower network, CPU, and memory counts, because the smaller amount of code you have to execute on the browser, the better. The second one is to tackle other key views. So we mentioned at the very beginning, and you probably already forgot, that's fine, that view page is the one we're focused on because it's 70% of our traffic. But that still leaves 30% that is other views. In particular, home and edit are the ones that are a little higher traffic. Home, if you saw maybe in one of the presentations, or if you go to our booth, we can show you what the new home looks like. Then the third one is about targeting corner cases. And I put corner in parentheses, in quotes here because there aren't really corner cases. There aren't such unusual corner cases that we don't see them at all customers, right? Everybody's got large pages. Everybody's got pages that have third-party macros in them. And they all exhibit problems of one kind or another. We need to know what those are because we don't always see them. We can't always replicate them. So the best way to give that kind of feedback, file a support ticket, work with support. It'll get it up to us eventually. If you manage to find me on Twitter, I tweet very rarely, but if you find me, go ahead and at me and just say, hey, I've got this page. I want you to take a look at it. I don't mind, though my support people would say, contact support first. Then when it comes to third-party macros, if you find that there are ones that are slow, you should escalate that to first the third-party provider. Right? And you should be able to tell them, hey, I love your macro, I'm trying to use it, but it makes this page load so much slower. Right? They're going to have a lot more control over that than we are. Thank you for your time.